Assalamualaikum warahmatullahi wabarakatuh. My name is Ilma Nurul Rachmania. Today I will present my final exam of Advanced Statistics using multiple regression with the title The Relationship Between Service Quality and Customer Satisfaction in Indonesia Cellular Telecommunication Industry. The introduction. The increasing number of mobile users in Indonesia doesn't in line with the average revenue per user. The decline ARPU was possibly due to the low-cost strategy to gain more market share. One of the reasons this strategy was taken is because the competition in cellular service industry is very tight since the number of service providers in Indonesia is very large compared to other countries. The purpose of this study is to find the relationship between service quality and customer satisfaction in cellular service in Indonesia. The research question to be answered is what are the factors that influence customer satisfaction in cellular service industry. These are the proposed framework of this study. Service quality contains network, reliability, assurance, responsiveness, and empathy, and how the relationship between the customer satisfaction. Several hypotheses that will be tested in this study are shown in the slide. There are 6 hypotheses. Questionnaires were systematically distributed utilizing a non-probability convenience sampling with a total of 215 respondents from walk-in customer at marketplace, educational institution, and also using online survey. The questionnaire was framed into the format of itemized Likert scale of 1 to 7. To test several hypotheses proposed, multiple regression analysis was used. Multiple regression is a statistical technique that can be used to analyze the relationship between a single dependent variable and several independent variables. The objective of multiple regression analysis is to predict the single dependent value. Classical assumption tests are requirement tests for the multiple regression that use ordinary least square technique. 5 types of tests that require and fulfill the assumption for multiple regression are normality, linearity, multicollinearity, autocorrelation, and heteroskedasticity. The first test of this study is the normality test. Normality tests are used to determine whether a dataset is well modeled by a normal distribution or not, or to compute how likely an underlying random variable is to be normally distributed. Various tests are introduced to assess the normality, such as normality probability plot, Q-square test, or using Kolmogorov-Smirnov test. In this study, the author was using normality plot for assessing the normality. Normal probability plot compares the cumulative distribution of actual data values with the cumulative distribution of normal distribution. These are the normality tests for this study. From those figures, it can be seen that all the line representing the actual data distribution closely follows the straight diagonal line. Thus, all the variables are on the normal distribution. The second test is the linearity test. The linearity of relationship between dependent and independent variable represents the degree to which the change in the dependent variable is associated with the independent variable. As seen on the slide, there's an ANOVA table for network variable and ANOVA table for reliability variable. As seen of the table, the significance of both variables is below the alpha. On the next slides, we can see the ANOVA table for responsiveness and assurance variable. As we can see, the significance for those variables are below the alpha. And the last is the ANOVA table for empathy variable. The significance for empathy variable is below the alpha. From those tables, it can be found the significance value of linearity for every independent variables are below the alpha. Thus, all the independent variables are linear with the dependent variable. The third test is multicollinearity test. Multicollinearity is a statistical phenomenon in which 2 or more predictor variables in a multiple regression model are highly correlated. The consequences of model that has high multicollinearity are increased standard error of estimate of the beta, often using and misleading result. There are 2 common measures for assessing multicollinearity. First is tolerance, and the second is variance inflation factor, or VIF, which is calculated simply as the inverse of the tolerance value. As seen on the slide, there's a table of coefficient for this study. The generally accepted levels for multicollinearity are if the tolerance values above 0.10 corresponding the VIF values to 10. As seen on the table, the VIF of this study are below 10, so thus in this study there's no multicollinearity. Another test is autocorrelation test. Autocorrelation is correlation of error terms. In regression analysis, each predicted value is independent, which means that the predicted value is not related to any other prediction. To examine the autocorrelation, one of the widely known tests is the Durbin-Watson. As seen on the slide, there's a table of model summary for this study. The Durbin-Watson for this study is 2.031. Moreover, Al-Ghifari in 2009 stated if the Dewey value is between approximately 1.66 to 2.34, it means there's no autocorrelation. If the Dewey value is between 1.08 to 1.66 or 2.34 or 2.92 means there's no meaning or conclusion. If the value above 2.92 means there's a positive autocorrelation, while below 1.08 means there's a negative autocorrelation. Therefore, there's no autocorrelation in this study because the Dewey value is 2.031. The next test is the heteroskedasticity test. Heteroskedasticity test is used to measure the constant variance of error term. When the error terms have increasing or modulating the variance, the data are said to be heteroskedasticity. Diagnosis was made with using the residual plot. As seen on the slide, this is the residual plot for this study. The variance error of prediction in this study are approximately the same for all predicted values. Thus, the following residual plot shows data that are fairly homoskedastic. After completing all the tests for regression analysis assumption, let's begin to analyze the data with using multiple regression. The most commonly used measure for assessing prediction accuracy in multiple regression is the coefficient of determination or R-square. R-square represents the amount of variance in the dependent variable explained by the independent variables. Two basic forms to test the hypothesis are F ratio and a partiality test for each regression coefficient. As seen on this slide, there's a table of model summary. As presented in table, the correlation coefficient R is 0.858, showing that the relationship between the independent variable and dependent variable is very strong. The determination coefficient R square explains the percentage of influence of the independent variable to the dependent variable. The determination coefficient R square is approximately 0.736, means the independent variable used in the model explains 73.6% of dependent variable. As seen on the slide, there's an ANOVA table for this study. From the ANOVA table above, the significance of F ratio of this study is lower than the alpha. Thus, this multiple regression model is statistically significant. Therefore, service quality has a significant influence on customer satisfaction. As seen on the slide, there's a coefficient table for this study. Statistical significant testing for the estimated coefficient in regression analysis is appropriate and necessary when the analysis is based on sample of population rather than a census. Based on the table coefficient, the significant value for the reliability, assurance, and network are below the alpha. Thus, partially reliability, assurance, and network is statistically significant, while the significance value for responsiveness and empathy are higher than alpha. Thus, partially responsiveness and empathy is not statistically significant. Therefore, network service has a significant influence on customer satisfaction. Service reliability has a significant influence on customer satisfaction. Service responsiveness has not a significant influence on customer satisfaction. Service assurance has a significant influence on customer satisfaction. And service empathy has not a significant influence on customer satisfaction. From the ANOVA table and coefficient table, the resulting equation that explains the relationship between service quality and service satisfaction in cellular telecommunication industry is service satisfaction equal to minus 0.246 plus 0.221 reliability plus 0.077 responsiveness plus 0.256 assurance plus 0.046 empathy and 0.473 network. With this equation, the expected customer service satisfaction level for any customer could be calculated from the service quality perspective of the customer. The model shows that the level of service satisfaction is influenced by network, assurance, reliability, responsiveness, and empathy. The conclusion from this study, it is proof service quality has a significant impact on customer satisfaction. It is all explained by the high value of the coefficient determination, and the level of service satisfaction is influenced by network, assurance, reliability, responsiveness, and empathy. As the aim of this study is to find the relationship among construct, multiple regression is the right method to analyze the data. This study also has met all the assumptions of multiple regression. The limitation of this study is regarding the size of sample, which are only 215 samples. Furthermore, to provide even more convincing evidence for the causal relationship among construct, additional longitudinal research is needed with added more samples before generalization can be made. The market competition in cellular service will inevitably become much more intense in the next following years. Therefore, firms are expecting to build and maintain competitive advantage by improving the service quality in achieving higher customer satisfaction. That's the end of my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.